Graphs of reaction kinetics. So we'll start with rate versus concentration graphs for a single reactant A. On the y-axis we have rate, on the x-axis we have concentration. So we'll start with a zero-order reaction. That's where the concentration of A does not affect the rate of reaction. So the rate concentration graph is a horizontal line. And here we have the rate expression, so its rate equals K. Because the order of reaction is 0 with respect to reactant A, we don't include it in the rate expression. Next is a first order reaction. The rate of reaction is directly proportional to the concentration of A. So we have a straight line that passes through the origin. And the rate expression is rate equals K multiplied by the concentration of A. Next is a second order reaction. Here the rate is proportional to the square of the concentration of A, and we have this curved line. The rate expression is rate equals K times the concentration of A to the power 2, and the gradient is proportional to the concentration. So next we have graphs for the concentration versus time. On the y-axis we have concentration, on the x-axis we have time. So for a zero-order reaction, the rate equals K, we have a constant rate, and the gradient of the line equals K. Next is a first-order reaction. The rate equals K times the concentration of A, and we have this curved line. The rate is decreasing with concentration. And finally, a second-order reaction. We have this curved line, and the rate equals K times the concentration of A to the power 2. So here's an example question. A student experimentally determined the rate expression for this reaction to be rate equals K, the concentration of the thiosulfate ion to the power 2. And you're given 4 graphs A, B, C, and D, and which graph is consistent with this information. So we look at A first. None of the graphs that we looked at just now have this kind of shape, so it's not A. C, we've seen this kind of graph before. This is a zero-order reaction. D, this is a first order reaction, and B, this is a second order reaction. So because overall this is a second order reaction, the correct answer is B.